Kindly do this and tell me while you're doing it, you can also keep saying it aloud, the steps that you're taking, so that we can do it together. Yes.
Now, first you write root 45 into 5 into 9
5 into 9. Okay. Then
minus 3 root 5 into 4. Can you hear me?
yeah, I can hear you now.
So, 3 root 5 into 4
Okay. 5 into 4. Good.
plus 4
Hmm.
root 5.
5. Okay. Then
Now, after this, we take 5 out.
we take 5 out.
This now is common.
We
Now,
should
first,
take 5 out, or we should, what should we do first?
do the constant. 3
Hmm?
minus 3 plus 4.
Minus 3 plus 4. Okay, wait a minute. Right now, this 5 is associated with another number. It has 9 with it. So can we first take the 9 outside?
Yes, ma'am.
Okay. So when we take it outside, what does it become?
9 root 5.
It becomes 9 root 5.
Now we take 9 out, right?
Okay, tell me one thing. What is root 9 equal to?
Now root 9 equal to 81.
Root 9 is 81, or
Oh,
then what
root
is
9
9
equal to
square?
3. 3.
Ah, root 9
3.
is 3. So this basically over here is root 5 multiplied by root 9, is it not?
Yes, ma'am.
And root 9 is
3.
root 9 is 3. So this becomes what? Root 5 multiplied by 3, yes?
Yes, ma'am.
And that is basically 3 root 5.
Yes.
Yeah.
Now after that we take 4 out
Then how, what does it
as
become?
2. 2.
2. First we have this 3, okay? So we're going to write this 3 multiplied by 2 root 5. Then
Plus, ma'am, we write it as it is.
plus 4 root 5. Okay. So this becomes, now what do we write?
Ma'am, we multiply 3 to.
3 and 2, okay.
After that we add 4 and 3.
Okay. So keep doing this simultaneously in your notebook.
Yes, ma'am. Ma'am, 3 root 5 plus 4 root 5 minus 6 root 5.
And that is
Ma'am, 1 root 5.
root 5. Okay. Let's do a similar question. Another similar question. Okay. So we have root 24 by 8 plus root 54 by 9. What should we do first?
Root 24 goes to 6 into 4.
Very good. 6 into 4. Or let's write it as 4 into 6. Okay. I mean, it's the same thing, but let's just write it as 4 into 6. Then 54,
Ma'am, 9 into 6.
9 into 6. Next,
Ma'am, we take 9 and 4 out.
then that becomes
Ma'am, 3 and 2. 2 and 3.
hmm, so 2 root 6 by 8 plus
3 root 6
hmm,
by 9.
by 9. Now we do the cancellations. Tell
Cancel,
me what we have after the cancellations.
ma'am, root 6 by 3.
Yes.
And
Root 6 by 3, the
no,
first
ma'am,
one.
I'm doing the second one
Acha,
first.
okay, okay, okay.
Ma'am, this second one is root 6 by 4 and
Good.
root 6 by 3.
Then final answer.
Ma'am, do you have to do the LCM?
Yep, we have to do the LCM.
Ma'am, multiplied by 3, first one, and then multiplied by 4.
So this becomes,
Two
tell
one,
me the final answer.
7 root 6 by 12.
Very good. 7, 6 by 12. Very good. Okay. Let's do some difficult question. Okay. Let's do this one. You have to rationalize the denominator. Okay.
Yes, ma'am.
4 root 3 plus 5 root 2 by root 40 root 48 plus root 18. This is 2 by the way. Hmm. So what do we do first?
Ma'am, first we do root 48 is. Ma'am, can we straight up do it like uh, by root 48 plus
Yeah,
root 2? You
root
can do it.
for what did you say? Is we should do
Root
what?
48 into root 48 plus root 18
Plus or minus?
minus.
Minus. Yes, we can do that. Then so you keep solving it simultaneously and tell me what you get after solving it.
Yes,
Hmm.
ma'am.
Each step, tell me that okay, in this step we did this, in this step we did this. So step by step we'll go together. Okay, you will do one step and then you will tell me, then I'll write it down.
Can we do root 48 equal to 3 into 16?
Yeah.
And root 18 3 into 6?
Yes. Hmm. Then what is your numerator? Tell me what you're getting.
I'm doing it now.
Actually, see, you don't have to solve for root 48 right now. Why? Because once you uh, do this in the denominator, like this one, you obviously have to solve, but the denominator is going to, it's gonna be rationalized by itself. So you don't have to solve the denominator. You don't have to expand the denominator right now. You can just do the
Root
identity
48
part.
square.
Yeah, so it's going to be root 48 square minus root 18
Root 18
square.
square.
And
Minus 18.
48 minus 18 is
48 minus 18 is 30.
30. Okay, and what do we have in the numerator?
4 root 3 plus 5 root 2
Hmm.
into uh, 3 root
Yes.
16. 3 root 3 into 16.
Okay, one sec. So this thing we had, okay. Now what I'm going to do is, I I didn't solve it over here. In the second step, I didn't solve it. Now I will solve it after I have expanded this entire numerator. Then I will solve the these 48 and 18. Okay. So first I'm going to write all of these terms down. So I'm going to write it like this: 5 root 2. I'm just expanding. Okay. So
Yes, ma'am.
these two terms are done. This term is done. Now I have to multiply both of them with this one. So which is now we can do what you were saying. 48, we can write it as, or let me just write it in a rough column over here, that wherever I have root 48, I am going to write it as root 16
16 into 3.
into 3. So that can be written as 4 root 3. Yes.
Yes, ma'am.
Okay. So I'm going to write for root 48 as 4 root 3. And I'm going to write root 18 as what?
3 into 6.
How about 9 into 2?
Yes,
Because you
ma'am.
see, if you have 3 into 6, this is not going to help you at all, because you can't take 3 out, you can't take 6 out. Then you have to further factorize the 6. You're going to say this is 2 into 3. Then you're going to take this 3 and this 3 out. So instead of that, let me just write it as 9 into 2. Okay. So this can be written as 3 root 2. Fine till here.
Yes, ma'am.
So I'm going to replace root 18 with 3 root 2. All right. Let's do this then.
Inf-
Yeah. Are you done till here?
Yes, ma'am.
Okay. Now tell me what should we write next?
Now we can cancel 4 root 3 and 4 root minus 4 root 3.
Wait, what?
4 root 3 and minus 4 root 3.
Where is but these are one term. It's not, it's not 4 root 3 minus 4 root 3. This is 16 into 3 minus 12 into root 6. So you cannot cancel them. Are you understanding the difference?
Yes, ma'am.
So first you have to solve them. What does that mean? This is one term, you have to solve it together. This is one term, you have to solve it together. This is one term, you have to solve it together. And this is one term, you have to solve it together. So first solve these and then we'll get to the cancelling part.
Yes, ma'am. Ma'am, 16, 3. 16
16
with 3.
into 3, and that is
40.
48. Then plus. Hmm.
And can you multiply this?
Mhm. Go ahead.
No, I don't know how to do this.
Which one? You don't know how to do this? 5 root 2 into 4 root 3? Okay, see. Let's do it step by step. We have 5 and then it's multiplied with root 2. That is multiplied with 4 and that's again multiplied with root 3. So they are all multiplied with each other. So we can have 5 into 4, which is
20.
20 multiplied by again root 2 into root 3. What is that?
Ma'am, root 2 into root 3.
That is root 6, no?
Ma'am, root 6.
Root 6. So what is the answer?
Ma'am, 20 root 6.
20 root 6. So now you understand how do we multiply this?
Yes, ma'am.
So it's 20 root 6.
Ma'am, 12,
Are you
12,
writing it simultaneously in your notebook as well?
12 root 6.
12 root 6. Are you writing it in your
Yes, ma'am.
notebook?
Ma'am, and then minus 15 root 2. Minus 15 into 2.
15 twos are
30. 30.
30. Okay. And what we do now is we take 40 and 13, sorry, 40, 48 and 30, and we solve them together. Then we take 20 root 6, 12 root 6, and we solve them together. So go ahead, solve them and tell me what you are getting, okay?
Ma'am, 18 minus 8 root 6.
Root 6, good. Now uh, we can take what as common? Let's take 2 as common, okay? 9 minus 4 root 6 by 30. So this becomes 15.
15.
So what are we left with? 9 minus 4 root 6 by 15. This is the answer. Is that okay?
Yes, ma'am.
Okay, so these were just a few questions. Now let's just do one more and then we will move ahead with our chapter. Now over here, what you have to do is you have to find the values of A and B, okay?
Yes, ma'am.
This is pretty easy. Root 2 plus root 3 divided by 3 root 2 minus 2 root 3. Are you doing it in your notebook?
No, I'm copying it out right now.
Copy it down. Keep doing it simultaneously, okay? Don't just look at the screen. You have to do both the things at once. Huh. When you're done, tell me how do we go ahead with this.
And there's no A in this.
Sorry?
There's no A in this.
Yeah, there's no way in this. Actually, there are more questions of this type. All right. And some of them have A, some of them have B, and some of them have both. So this one has only B. So we'll just have to find B. Right?
No, we can't subtract the denominators, right?
We can't.
Subtract the denominators.
No, we can't. Because there are 3 root 2 and 2 root 3. Root
And
2
we
and
can't
root 3.
cancel either.
Sorry?
And we can't cancel them.
Yeah, we can't cancel them. So what do we have to do? Think.
Add 1 to the numerator for both.
What will that do?
Root 6 by.
See, first we have to rationalize the denominator. Okay. Why? Because you can see that on the RHS, there the denominator is 1. Yes. On
Yes,
the
ma'am.
RHS, the denominator is 1. And in the root is only there in the numerator. So we can clearly see that this is a type of, or the RHS, they have rationalized the denominator for the RHS. But on the LHS, the denominator is still irrational. So what we have to do is first we have to rationalize the denominator. So do that, rationalize the denominator of this one. You have to multiply the fraction with what?
Yes.
What should we multiply the fraction with for rationalizing it?
Ma'am, 3 root 2 plus 2 root 3.
Yes, good. So multiply and tell me what do we get. Tell me what you're getting in the numerator and what you're getting in the denominator.
Denominator 0.
Denominator is 0.
No, ma'am, sorry. Yes, ma'am. 6 minus 6.
6 minus 6. Are you sure? This
Yes,
is
ma'am.
9 2s are 18. This is okay. What are you getting in the denominator? First look at this step.
Yes, ma'am. I got a little mistake.
Where was your mistake?
Ma'am, I forgot to square 3 and 2.
Hmm.
6, ma'am.
Yeah. Now numerator. Just look at the numerator values and tell whether you have gotten the same values or not.
'Ma'am, you add root 2 plus 2 root 3. You add root 3 plus 2 root 3.
Which one are you talking about? Which term are you talking
Numerator.
about?
Numerator, ma'am. This
Yeah.
root 3 and 2 root 3.
Root 3 and 2 root 3. Where do you have root 3 and where do you have 2 root 3? Which one? Like I have colored them so you can talk about which color are you talking about? Which one are you talking about? Are you talking about this step or this step? First or second?
First one.
Okay. Where do we have root 3 and 2 root 3 over here?
Ma'am, root 2 plus root 3.
Root 2 plus root 3. Can we add them? Are they like
No, ma'am.
terms?
No, ma'am. So, ma'am, you either have to add the whole term or you can't add them.
Yeah. See, imagine if I had something like x square plus y square multiplied by uh, x, let's say, yeah, multiplied by x plus y. Let's say we had it like this. Okay. Then can you add x square and y square? No, you cannot because they're not like terms. So what you have to do is you have to first multiply it. You have to open the bracket. Okay. That's what we are doing. We are opening the bracket here. First, we see whether we can add it or not. So we can clearly see that this root 2 and root 3, they cannot be added because they're not like terms. Similarly, 3 root 2 and 2 root 3, we cannot add them. So the only option remaining is to open the bracket. How did we open the bracket? First, we did root 2 multiplied with the first number, which is 3 root 2. Then we did root 3 multiplied with the first number. Okay, you can see root 3 multiplied by 3 root 2. Root 3 multiplied by 3 root 2. Then we did the same thing with the second number over here. So what we did was root 2 multiplied with 2 root 3. You can see over here. And then root 3 multiplied with 2 root 3. You can see over here. So that's how we have opened the bracket. Is it clear?
Yes.
Okay.
Ma'am, 6 plus 3 root 6 plus 2 root 6 plus 6.
Good.
You can
Don't
add
copy
6.
it. We can add 6 and 6, and this 3 root 6 and 2 root 6. Again, we can add that because 3
Yes, ma'am.
root 6 and root 6, right? So we can add those two. 3 root 6 plus 2 root 6 becomes 5
5
root
root.
6. Okay. Don't copy it down. Just
Ma'am,
solve it from your own, using your own steps.
ma'am.
Done. Are you done till here? 12 plus 5 root 6.
Yes, ma'am.
Now look at the RHS. The RHS is 2 minus b root 6. Now, basically what they are saying is this thing should be the same as 2 minus b root 6. Can you guess what is the value of b? What is the value of b? Does this look like this? The only thing that we can see is common is root 6. So how can we bring this to this form?
Linear equation.
Sorry. See, over here we can see that 2 is separate. This is the rational part. And minus b root 6 is separate. Yes, this is the irrational part. Irrational part. So let's do that. Let's separate them. Abhi to what's happening is there is rational part plus irrational part divided by 6. So let's separate them. How do we do that? We can do that by separating this fraction. 12 by 6 plus 5 root 6 by 6. Can we do this? Yes or no?
Yes, ma'am.
Yes, we can do this. So tell me now, what does it become? What is the value of b? See, this is our
Ma'am,
2.
5
Hai
by
na?
6. 5 by
Yeah,
6.
good. This is our 2. So this is the same as 2. No, not 5 by 6. Minus 5 by 6. Because it is 2 minus b root 6. So our b happens to be minus 5 by 6. Getting it?
Yes, ma'am.
B is equal to minus 5 by 6. Any doubt?
No.
Then I believe we can move on. Okay, so I believe we have completed the first chapter. Let's move on to the second chapter then.
Yes, ma'am.
So the second chapter is about polynomials. So just give me a second. Polynomials. What do you know about polynomials? What are polynomials? Yeah.
It's an algebraic expression.
Okay. Algebraic expression. Algebraic expression. We have something like x to the power 1 by 2 minus 2. Okay. This is an algebraic expression. Is this a polynomial? Hmm?
No, ma'am.
No, why not?
The power.
Power of x. So what should the power of x be?
Ma'am, 2 or 3.
2 or 3? It cannot be anything other than that.
No, ma'am. It has to be 1 till how much? It is
It has to be
1 or more.
1 or see. So there are two things about what the power of the variables. The power of the variables, it cannot be a fraction, okay, and it cannot be a radical. Radical means root. Basically this is the same thing. It cannot be a fraction or a radical, and it cannot be negative. The power of variable cannot be, repeat, it cannot be,
Fraction or radical or negative.
yeah, it cannot be negative. So tell me about this. What about x plus 1 by x? Is this a polynomial? First of all, is this an algebraic expression?
Yes, ma'am.
Yes, it is an expression. But is this a polynomial?
Yes.
No, it is not a polynomial. Why? Because look at this one, okay? So this is x, and what is this? What is 1 by x? It can be written as x to the power
1 by 2.
minus 1. X to the power 1 by 2 is root x.
Yes, ma'am.
But you know that anything to the power minus m is can be written as 1 by a to the power m, right? So 1 by, or in other words, x to the power minus 1 can be written as 1 by x to the power 1, yes?
Yes, ma'am.
Yeah. So we can say that this is negative power. So if it is a negative power, it cannot be a polynomial. So the rule of thumb is the power of all the variables should be a whole number. Yes, it should be a
Ma'am.
whole number.
Ma'am, the power can be 0.
Yeah, 0 is a whole number, isn't it?
Yes, ma'am.
Hmm. Okay. Now it should be a whole. Mm-mm-mm. All right, let me just give you some examples, okay? Okay, before we do examples, let's talk about something called degree. Do you know what's a degree of a polynomial?
The highest power.
The highest power. So now let's do some questions on degree of polynomial, okay? What is the degree of, okay, let's start with an easy one. X to the power 5 minus x to the power 3 plus 4.
5.
Degree is 5. Okay, what about 7? This is a polynomial, right? Is it a polynomial? Yes or no?
Yes, ma'am.
What is the degree of this polynomial?
1.
1. Okay, then what is the degree of this polynomial?
1.
Now tell me, what is the degree of this polynomial?
0.
0. Very good. Okay. Now let's do a few difficult examples. Okay. Oh, wait, this is not difficult as such, but let me tell, let's just see this one. 5t minus root 7. Is this a polynomial? Yes or no? Yeah,
Yes, ma'am.
it's a polynomial. What is the degree of this polynomial?
Ma'am, 1.
1. Very good. Okay. Just a minute. Let me just see some questions on this. Okay. What is the degree of this polynomial? Y cube 1 minus y to the power 4. Yes.
Ma'am, 3 into 4.
And what is 3 into 4?
12.
12. Very good. Okay. Uh, how about okay. Yeah. Is this a polynomial or not?
Yes, ma'am.
It is. What is the degree of this polynomial?
3.
3. Okay. Mm, let's solve it. Okay. Let's solve it. So this is what a plus b whole square. So this becomes what? Tell me, what should I write?
Ma'am, 4. Ma'am, sorry. What did you
I'm
ask?
asking you, what do I write next?
Ma'am, x square.
See, x to the power, yeah, not x square, x to the power 1 by 2 whole square plus, because this is a, this is b, and we have to do a plus b whole square. So a square plus b square plus 2ab, right? So a square plus 2ab, which is 2 into x to the power 1 by 2 into 2x to the power 3 by 2, 2ab plus b square, which is 2x to the power 3 by 2 whole square. Fine.
Yes, ma'am.
Okay. Now this becomes, tell me if you've done writing till here.
X.
Are you done writing till here? Okay, you're writing. Let me know when you're done.
Done, ma'am.
Okay. So next, let's continue. X to the power half whole square. What's that?
1. X.
X to the power 1. Okay, so x plus, next, what is this? 2 into 2 into 2 first of all. This is 2 multiplied by 2, which is 4. So I'm just going to write 4 multiplied by x to the power half into x to the power 3 by 2. That becomes,
X square.
this becomes x to the power half plus 3 by 2, which is x square. Okay, then plus
2, 4. 4x cube.
4x cube. So this is the polynomial, and the degree of this polynomial is
3.
3. Okay. Huh. How about this question? You have x. Used to be there. Yes.
Yes, ma'am.
So anyway, let's move on. Okay, so you know what is a monomial, binomial, trinomial?
Yes, ma'am.
What is monomial? Give me an example of a monomial.
Ma'am, 1x.
1x, okay, or just x. Okay, then maybe maybe I can write 5x square. This is also a monomial, right?
Yes, ma'am.
Then can you give me an example of a binomial?
Ma'am, 2x plus 5.
2x plus 5, very good. Trinomial.
Ma'am, 3x square plus 2x plus 1.
Okay, good. Uh, okay, all right. If I ask you, what is the coefficient of x square in this polynomial? What is the coefficient of x square?
3.
3. Okay, very good. Um, okay, so apart from these, there's something called linear, quadratic, and cubic polynomials. Do you know what these are?
Yes, ma'am.
Okay, can you give me an example of a linear polynomial?
Ma'am, highest degree is 1.
Very good. Highest degree is 1. For example, this
X.
one is a linear polynomial, right?
No, I can't see anything.
You can't see.
No, I can't see anything written. No.
I'm talking about this one, 2x plus 5.
Yes, ma'am.
Is it visible to you?
Yes, ma'am.
Okay. Next, quadratic. Can you give an example of a quadratic polynomial?
Ma'am, 3x square plus 2x plus 1.
Very good. So this one is quadratic. Can you give me an example of a cubic polynomial?
Ma'am, 3x cube plus 2x square plus 1x plus x
Okay,
plus
3x
5.
cube. Let's just say 3x cube plus 5. Okay.
Yes, ma'am.
This is also a cubic polynomial. Okay. What is where do we get this word from? Linear. Why do we call
Um,
it linear?
because it's single.
Single variable. See, we call it linear because when you there's something called a graph of a polynomial. Okay. So the thing is, if you have a polynomial, you can always plot a graph for it. For example, let's say you have x plus x plus 2 equals 0. Okay. Now what we're going to do is we're going to take out our graph sheet and we're going to say that what if my x is, let's say, 0? If my x is 0, then this entire thing becomes what? 0 plus 2. And what is 0 plus 2?
2.
2. So when my x is 0, so this is 0, 1, 2, 0, sorry, 1, 2. So when my x is 0, my answer is 2. So this is my point, 0, comma 2. Okay. Let's say now if my x is 2, or let's say my x is 1. If my x is 1, then what does this entire answer become? 1
3.
plus 2 is 3.
3.
So 1 and then 3. So 1 comma 3 lies over here. 1 comma 3. So the thing is, when you connect all of these points, when you put in all the possible values of x and you connect all the points, this turns out to be a straight line. When you connect all the points, it will connect to give you a straight line. That is why, that is where, from where we get the word linear. Because when you plot such a polynomial on a graph, the shape you get is a straight line. Okay. Similarly, 2x plus 5, if you plot it into a graph, you're going to get a line. I'm going to give you a homework. Okay. Go to GeoGebra, not right now, after your class, .org/calculator. Okay. And if it asks you which type of calculator, just click on graphing calculator. And it's going to, let me just show you on the screen. Actually, I can't share my screen right now. But over there, it's gonna ask you what input do you want to put. Okay. So in your input, just write 2x plus 5. This one, 2x plus 5. And tell me whether you're seeing a straight line or not. Tell me where that line is cutting the x-axis. You know, this is the x-axis and y-axis, right? You're aware
Yes,
of that, right? So tell me where that line is cutting the x-axis, on what point, and on what point it is cutting the y-axis. Can you do this homework? Yes? No. I can't hear you. Okay, and from where do we get this word quadratic? Jabbar?
ma'am. 2.
Yeah, quad. Okay, fine. We get it from 2. What about cubic? Obviously, 3, right? All right. So that's it for today's class. We just had a brief introduction of the first chapter. Your homework is the entire first exercise. Okay.
Yes, ma'am.
Homework is the entire first exercise.
Ma'am, 2.1.
Yeah. Point one.
Okay, ma'am.